It's a pleasure to be here today, and I hope that my presentation will be somehow interesting for the people. So, as I said, Kojunin, this takes its roots from the Japanese culture, and Kojunins were bodyguards. And they were foot soldiers guarding shogun itself. What it means that this concept, what we presented, that what we want to introduce to IoT and edge and fog computing is something that should protect basically the data itself. It should protect messages regardless if they are being stored at the rest or they're being exchanged between different nodes in an IoT ecosystem. This is why we came to the idea to go with this concept, and what that concept exactly means I will show you a little bit later. But let me first drive you to understand what are the market trends and challenges, basically to understand why today data monetization, data privacy protection, zero trust, different concepts that we are listening every day from different sides are very important for the business, especially not only for cloud computing, but also for this kind of hybrid approaches where we have data being collected at the edge sites, but also transferred through the whole ecosystem until they reach the main brain of the system on the cloud. If you take a look 2 years ago, for instance, for the hype cycle from Gartner related to privacy, we saw that data security governance, zero knowledge proofs, decentralized identity, also homomorphic encryption, differential privacy, these are all topics which are attracting attention because it's very important that privacy management, privacy control, and data-centric security capabilities are very important in newest applications. So we reach a level where we generate, and we generated a lot of data. So we are speaking about huge amounts that needs to be protected, because even if we want to do some AI related stuff in future with those data, we need to be sure that the data was not poisoned, that the data was protected in a proper way, basically at its very source, meaning that if we are speaking, for instance, in IoT-related domain, any sensor which is generating certain data needs to protect that data at the very source. And this is where we are seeing that maybe approach that we are proposing that I'm going to present today is something that could be very innovative and very important for different applications which are targeting IoT ecosystem. So back in 2021, we see that there have been a lot of importance given, especially through the innovation trigger area, to technologies which are targeting privacy and which are targeting how to protect the privacy, even if the data is not only at rest, but if data is being also shared among different parties. The same trend has been seen back in 2022. I believe that in 2023 we will see also the same trend with some additional technologies that can solve certain issues. So still we are speaking about zero knowledge proof, homomorphic encryption, data security platform. And it's very important to have this kind of privacy preserving messaging protocols, which will prove that information which is reached at the end, which reaches its destination, is correct. So this is important not only to protect the privacy, because in most cases we can speak about very sensitive data being transferred from one point to another, but we want also to say that this information that is then being sent to its destination must be correct. And in that case, we are sure that a large amount of data being collected by the brain on the cloud side can be sure that afterwards the trained models, which are going to be trained further, for sure have reliable data, and that data has been also proven from its basic route where it has been generated. And taking all of that into account, we are speaking nowadays, and we are researching in our department technologies which can help and which can improve data security, not only through the application with what we are witnessing, because if we are speaking about the current challenges, we can see that we do have already data security, especially in the systems which are adopting attribute-based access control approach. But what is the problem there? It's the problem because we have limitations in data sharing flexibility, which means that any consumer of the data must go through the governance system to access the data. So we cannot share the data outside of that application, outside of that ecosystem. If I want to send data to the third party, which doesn't belong to my organization, it can be very difficult, because in that case, attribute-based access control system implemented within the application itself doesn't mean much. Risk of data breaches through the backdoors is always present, and this is why we are speaking nowadays more and more about zero trust concept, how to protect data at every level and how not to trust to anyone. So to have a such system where the data must be protected at every moment. And of course, if we are speaking about just the masking capabilities of certain applications, it is fine. Masking will work as long as you're using a data governance system, but masking cannot support all use cases. So this is something that we need to find a way how to enable data to still adapt the policies which are, for instance, given through the application, but at the end, the data must show that it is being protected till its moment of generation during the whole life cycle of the data until the disposal. This is what we want to achieve, and this is what we are already working on inside of the cloud platform, but we also extended our researches a little bit. So we are trying now to cover also Internet of Things domain, especially by speaking about fog computing, where we're having different layers where data is being aggregated, processed, and stored. And according to that, we would like to present this concept, how it works, and what kind of benefits it brings. Before I start, let me just briefly explain you what kind of technologies, the core technologies we are using here. Technology which gives you this kind of possibility really to work outside of the application only, because if we are speaking about attribute-based access control, yes, it is providing you data governance, user management, everything through the application layer. If you want to control data accessibility, on the level of data itself, you need to adopt something new. And here we have attribute-based encryption technology. This technology is something that has been developed inside of the group. When I say inside of the group, I'm thinking of entity group, particularly by our colleagues from entity research. And all together with them, we started growing more business opportunities, not only business opportunities, but trying to extend more applicability of the technology itself. What attribute-based encryption is, so you can imagine it as a cryptography technology, which enables data access management in addition to encryption. So encryption plus access control of data layer altogether forms attribute-based encryption. What it means? It means that the whole data is encrypted by one master encryption key. It's encryption all of nothing. Then the manager or the data owner can create different decryption keys, and those decryption keys can be later distributed to different parties, which means that every party at the end will have a different key, which will be basically created based on the attributes and policies which are added, meaning that in this case, for instance, of medical use, doctors or financial department at the hospital, they will have different keys which will help them, which will enable them to access just that part of the information which is relevant for them. Why it is important? It is important because we can have fine-grained access to the data, which helps then basically to define the distribution of the keys, and the distribution of the data further means that one role can access one part of the information, another role can access another part of information. The rest of the information which is not assigned to that role or to these attributes will not be accessible by the third parties that would like to request the access. And here we come to two different implementations of attribute-based encryption. One is content-based access control, another one is role-based access control. And if you take a look at these two examples, here is where the difference is. For instance, in content-based access control, we have policies that are associated with users' private keys, and attributes are associated with ciphertext. In this example here, we can see that, for instance, we can encrypt complete data with the attributes, data, for instance, ID card or driver license from a person. Then we can distribute different keys, which are enabling access to just one information or several different attributes from the complete data that someone can access to it. And then we can say, okay, the encryption key, for instance, for face or date of birth will be given to one party or one set of people, and other keys can be distributed to some other party. On the other side, we have this role-based access control, which basically gives possibility for attributes to be associated with users and policies to associate them with ciphertext. What it means, if you take a look, for instance, this is one example that we don't really like to remember because it brings us to the COVID pandemic, but it was interesting there because with this kind of encryption, we can encrypt the whole data, but then doctors, nurses, or administrators can have access to different parts of information based on their keys. And still we are speaking about rules which are set inside of the attributes through which we can form the complete policy how we want to decrypt this key in the future. And these are two differences in terms of utilizing attribute-based access control from the perspective of data with this particular encryption technology. And this exactly gives us the possibility now to step out from the application context only, and then to be able to basically apply the context of encryption to the data itself, and then through that policy mechanism to define who will have access to which part of the policies. And this is what we are basically doing here. As I said, all together with our colleagues from NTT, today we are working on a big data governance platform, which will help to protect the data exactly from the source of the data until the very disposal, where basically the data will be encrypted at the beginning through the application itself, meaning that the policies from application now can be incorporated into the encryption mechanism itself. This is a general explanation of attribute-based encryption, but it's important for today's audience just to understand what we are trying to do and what is the starting point of this solution. Now, I hope you understood what attribute-based encryption means and how it differs from attribute-based access control. Once we have attribute-based encryption, we can now speak about how to protect data in fog computing scenarios. First, for some people, maybe fog computing is a new term. So what basically fog computing means, it's a kind of decentralized computing infrastructure which combines different edge devices and gives an additional layer for the computation, storage, or communication that can be done locally or that can cover a certain area. And basically, before it has been all transmitted to the cloud, there are certain fog devices or fog services which will do additional processing of the data. Basically, when speaking about fog computing, let's say it's kind of one step forward compared to edge computing, because in edge computing, we still can speak about the data which is completely being processed and analyzed on the edge side. Here we are doing more hybrid way, and this is very important for different applications, because through fog computing, we can use the benefits of collecting data in real time and doing some real-time operations at the edge, which are very important, plus forwarding certain amount of data, either previously pre-processed or in a raw format or in any kind of format further, where we have much more capable devices with more processing power that can do additional processing and then can give us more results until we reach the final stage of cloud computing, where we can collect historical data and we can provide much more insight of the data being completely collected from different sides. So this is why fog computing is getting a lot intention nowadays. So we can speak from smart city applications, smart industry, smart homes, buildings. So basically everything where we can connect IoT devices, but today it's not anymore just IoT, it's Internet of Everything. So it's IoE. Basically, with this fog computing concept, we are basically decentralizing computing infrastructure, and we are giving more power to the near-to-edge devices or services, which we call fog computers, and which can give us additional layer of processing before we can reach necessary results. When we are speaking about fog computing now, we can speak also about certain challenges that are appearing here. Data at rest encryption doesn't provide strong protection, especially if we are using already existing mechanisms. If we want to exchange messages, if we want to, for instance, in mesh networking, try to exchange also some messages between different nodes, or even if we want to broadcast messages to the wider audience, basically to broadcast them to the channel, we cannot guarantee that data being shared and data being transmitted in that case will be completely secured. Okay, we can rely on the mechanisms which are already incorporated there by different protocols. If we are speaking about Zigbee, Z-Wave, 6LoWPAN, any other kind of protocol IoT that today is helping us to transfer the message, but still, if we are sending it, for instance, a message to the broadcast channel, everyone that are listening to the broadcast channel will access the same message. If we want to do it more granularly, and if we want, for instance, to send different keys to those listening devices, then at the current implementation, it's a little bit complicated. And of course, there is a never-ending challenge about privacy, especially nowadays when we are challenging also a lot of regulations, also being upgraded from GDPR in Europe to some regulations from the US, Japan, and the rest of the world. There is a problem because not only security, but also privacy of information being shared. For instance, we are speaking about just the example a while ago about passports, COVID passports. If we share that kind of information, maybe someone who doesn't need to see all these parts of the information also listening at the broadcast channel will be able to access it. And this is part where we would like to give additional layer of protection and make more granular access to the data itself. So basically, these are some of the challenges that we identified from the perspective of data privacy and the way how the data is being treated and how data is being secured. And according to that, we are coming up with a proposal now after you have been aware of what attribute-based encryption is and what are some of the fog computing challenges that we identified. We can speak about the way how we want to secure data in fog environment. Imagine a network of different mesh nodes, IoT nodes. It's a mesh network, so every node can speak with others. Every node has access to different sensors, to different devices, so to different, how to say them, devices that generate data. Maybe not each of them should see what others are doing. Maybe some data here being collected from the sensors is sensitive and has to be additionally protected. And this is where, for instance, attribute-based access control through the application layer cannot help us because broadcast doesn't work in that case. In this way, we are proposing to implement at every IoT node, and basically we do have a solution, gateway IoT solution that implements already a driver for attribute-based encryption inside of the device itself, where we are having this lightweight version of ABE implemented locally. What it means? It means that nodes now can broadcast, instead of the message, they can broadcast ciphertext, and ciphertext is encrypted message. That ciphertext is now received by other nodes, which are in the broadcast range, which are connected to the broadcast channel, but only those that possess required keys, actually required attributes, can decrypt the message. And we can share and distribute different keys, meaning that different nodes in this case, like what we can see here in different colors, will be able to access different parts of the information. Imagine this like example, you're having a contract and you don't want that everyone in a loop sees all the details except, for instance, executive board. It means that executive board will have a key which basically shows all the data. And then different parties will have key which only access to the paragraphs which are relevant for that person, for that role, before that person gives consent after reading the decrypted data. So here is the same case. Basically, different keys can access different part of the information. If necessary, keys can access complete data being shared here. And in this way, when we are broadcasting message, so not only nodes which are connected to the broadcast channel now can access it, but also on the broadcast channel, we can control which node will access which part of the information. And this is something that also can help us in future to basically work in a more distributed way, because if you can imagine this kind of infrastructure with distributed nodes that communicate with each other, but still the communication and the level of data can be controlled, which will be disclosed, you can also think about distributing some parts of processing to different nodes, because if some nodes have more power than others, they will be able to process more data, meaning that with these keys mechanism, we can also select which data should additionally go to the processing or should be forwarded to more powerful nodes for the processing. This is something that we can think in the future, but at this moment, compared to traditional ABAC, attribute-based access control concept, basically cojunin concept that we are presenting today secures the messages being exchanged, and it also brings additional value, which means that it brings fine-grained access control on the level of data, meaning that now one broadcasting node can control which parts, which portion of the data can be distributed with other nodes. And this is what we are today working on, and this is where we are trying now to contribute basically to this additional security for fog and edge computing as well. And if you are speaking, for instance, just one example for smart home scenario, and in this scenario, we can, for instance, encrypt video. And this video is basically from surveillance cameras. So here, we can encrypt with attribute-based encryption with cojunin the video at the source. We have outdoor, indoor cameras, and then we can basically distribute different keys to end parties. Some keys can be basically distributed in a way that they unlock the access to the data regardless if it comes from outdoor or indoor camera. We can say it's owner view, so owner should be able to access to everything no matter where the camera is located, outdoor, indoor, and in which hours. But for instance, security monitoring company, which is doing security support for the owner, they can, for instance, get access to the data from both cameras, for outdoor cameras always, but for indoor cameras only outside of the working hours. If we're speaking about the office building, then of course, when no one is there, it is important for instance, for security monitoring company to be able to see the data, but still not to violate the privacy and personal information of people while they're located in the office. So this is how we can also control on a, let's say, timely basis, and not only timely basis, but also, as I said, there are different attributes which can help us how to control the data flow. Here in this case, we can control exactly which cameras when should be accessed by, for instance, security monitoring company. And then we can also give additional keys for camera manufacturer company, which will provide the access on demand just for troubleshooting purposes. And this can be additionally generated when it is needed. So this is a kind of how we can distribute the keys, how we can process the data, and we can immediately at the source pack the data, encrypt the data, and then be able, not through the application, but with the data encrypted at the data level, to share, to distribute it further, and then basically to provide more privacy for such data, more privacy concerns, and of course, not only privacy, but in general, protection of the data being further distributed. And if we are taking just what can we do now, with this cojuning concept. So speaking about this solution implemented on IoT devices, and as I said, in our company, we do have our implementation of IoT gateway that already has this kind of driver implemented inside of the system. And this is software framework that can really run on low-cost embedded devices. It can run on industrial PCs, so it doesn't matter. Basically, it requires Linux operating system on top of which it can run. But with such algorithm, not with algorithm, sorry, with such solution implemented and integrated, we can now protect the data at the source, so the raw data coming from sensors with different attributes and policies according to attribute-based encryption standard. We can keep the protection and retain it during a message exchange, either between different IoT gateways, if we are speaking about more decentralized approach and even distributed processing, or we can do the same between IoT gateway and the cloud. So what is IoT gateway in this case? Edge gateway. This is basically where we can retain the protection, and at the end, we can protect data at rest. So this is also very important because with such protection, we are not relying only on existing mechanisms from the storage devices, but we are also delivering our data protected, not in a raw format, and in future, roles that would like to access it, if they don't have proper key, they won't be able to access any part of the data, or they will be able to access only those portion of the data which provides them possibility to extract the information which are necessary. So this is basically what cojuning concept based is. And as I said, if you're getting back to the attribute-based encryption, this is really an innovative topic. And this is topic that the initial papers has been published several years ago, let's say, but still the concepts of implementing this solution and basically proposing this solution to the market is something that has been recently put into consideration. If you remember what we saw on the hype cycle diagrams, we saw that there are some technologies like homomorphic encryption. This is a different kind of encryption, but still provides certain mechanisms where you can protect the data and basically use the power of homomorphic encryption to compare the data encrypted against other encrypted data, which also gives additional possibility, and that is to keep the privacy and not to disclose any privacy, but to do mathematical operations over the data and get the results which are very relevant, particularly for the applications where you need to compare some results or some data, for instance, biometric authentication or any kind of data where you need to do some comparison. Here, with attribute-based encryption, it's a little bit different from homomorphic encryption, because here we are defining and using, so the data owner is the person who is defining and then providing keys that are incorporating policies based on attributes, and how he or she will distribute these attributes further, it depends from the data owner itself. So the complete policy for the key which is being built from attributes depends on the data owner and how the data owner defines it. So it's completely flexible. This depends who will have access to which part of the information. And as I previously presented, basically there are two different implementations, KPAB and CPAB, which are defining either we are going with role based access control, or we are going basically in a different way, and that's to protect the data at a more granular level, to be able to really reach the requirements of having secure data, data where privacy is protected, and data which not only protects data at rest, but also data being transmitted from one party to another.